So if we look at our textbook, this quadratic formula, this stuff right here, what that is if I complete the square and did the square root thing to the standard form of an equation and I solved it for x, this is what I would get. Okay? And so we're going to use, we can solve any quadratic equation, whether it's real or complex, it doesn't matter, real or imaginary, by using this formula. And so example number 4 says, why don't you go ahead and solve the expression 3x squared minus 6x equals 5. Okay, so that's what we're going to try to solve. And so I've written it down from the textbook. We're going to use this quadratic equation up top. And the first thing I have to do is make sure that it's set equal to 0. So how do I do that? Pretend Mr. Adams doesn't know how to do that. What do I do? Huh? Subtract 5 from both sides? Alright, we'll try it. Sounds good. So if I subtract 5 from both sides, I get 3x squared minus 6x minus 5 equals 0. Now, what this BAC stuff, what that comes from is that we always want to rig up our problem in a way so it looks like this. AX squared plus BX plus C is equal to 0. So if that's the case, then my A term here is equal to 3. My B term is equal to negative 6. And my C term is equal to negative 5. Now to solve the where this is going to cross the x-axis, the roots, or the solution, or the zeros, it's a lot of stuff, I'm just going to plug all this stuff into that formula. So I'm going to say x is equal to negative b plus or minus the square root of b squared plus, or I'm sorry, minus 4ac all over 2a. Whew, that's a lot of work. So then I'm going to say x is equal to minus, what's b? Negative 6 plus or minus the square root of negative 6, right, because that's b, minus 4 times the quantity a, what's a? 3, times c, what's c? Negative 5, all over 2 times a. I'm going to pause there. Do you see where I got all the numbers from? You should have learned this in Algebra 2, did you? Yeah? Okay, good. So now, let's crank through and do a little math. So now the next step would be x is equal to positive 6 plus or minus the square root of 36, and then 4 times 5 is 20 times 3 is 60. A negative times a negative is a positive. So this would be a positive 60. All over 6. Man, that's a lot of writing. Okay. So now in the next line, I gotta grab some more paper here. And the next line, what we need to do is start to simplify that. Now technically we could enter that in the calculator right now and we would have an answer. But the problem is if you don't enter it in the calculator correctly, you could get the wrong answer. I guess that's the same too if when we go to simplify this, we could make it the wrong answer. So in the next line what I want to do is, and I'll do it one step at a time, I'll say x is equal to 6 plus or minus the square root of 96 all over 6. Now for 96, there may be, you may be able to reduce that, it doesn't really matter. But now at this point I could separate these. And I could say x is equal to 6 plus or minus 96, or I'm sorry, I'm going to separate them. So I'm going to say big plus square root of 96 over 6, and x is equal to 6 minus the square root of 96 over 6. Now, Mr. Adams is pretty good at entering all this in the calculator in one step. You may not. So what I recommend, until you get the hang of this calculator business, is that you come in and do the numerators first. So I might do something like 6 plus the square root of 96. And that equals 15.79, right? And then what do? Now I divide it by 6, and I get 2.633, right? So for this one I get x is equal to 2.633. Okay, looks good so far. So now I'm going to do this again. I'm going to say 6 minus, this time, the square root of 96. Hit enter. And then divide by 6. And for this one I get x is, and technically Mr. Adams should use the approximation symbol, right? Because we rounded. Negative 0.633. Okay? Alright. So those are, oh wait, why did I write down the wrong answer here, you guys? You're supposed to tell me when I make a mistake. This answer is x is equal to, no, I had the right answer. What am I doing, you guys? X is approximately 2.633. So those are my two answers. Now what does that mean graphically, you guys? What does that mean graphically? Huh? That's correct. That's the points where it crosses the x-axis. So if I want to double check this, I can enter in the original equation. So let's look at that original equation. The original equation was 3x squared minus 6x. Now remember, we're always going to use it, we've got to set it equal to 0 first. So in this case, I'm going to put minus 5, and then I'm going to hit graph. Now our answers that we came up with were 2.633 and negative 0.633. So let's calculate that. If I hit second, trace, come down to find or calculate the zeros. I want to go a little bit to the left of this boundary. Whoops, that's right on it, isn't it? Enter. I want to go a little bit to the right of the intercept, and then I want to try to get as close as I can to the intercept. And sure enough, it's negative 0.633. Now let's do this again for the second x-intercept, or 0, or solution, or roots. Whew, that's a lot to say in one sentence. So a little bit to the left of the second intercept. Enter. A little bit to the right. And then we guess. And positive 2.633 if we round. Any questions?